Welcome to our presentation. Thank you for having us today. And we are going to talk about cloud robotics and basically how to integrate a system for what we can consider avatar robotics teleimmersion. And of course, we hope you enjoy the presentation. Basically, we have a team in the robotic lab at Central Washington University, and this was a joint implementation where basically the implementation, all the code is kind of a different blocks, and basically for the presentation today we are going to cover the following aspects of this implementation that of course is an ongoing project, right? So the idea is that we will discuss things such as the Spark system. We'll also talk about the Now6 humanoid robot, and we will mention about brain-computer interface, right? So again, I hope you enjoyed the presentation, right? So as I mentioned, the robotics lab was opened in 2017, and since then we, well, actually the proposal was made in 2017, and it was actually opened in 2018, right? So since then we had several students join all the activities we developed in the robotics lab, and also we created the data science club, which of course motivate and bring together all the students, and of course they enjoy very much all the activities and projects we are implementing. So of course we needed to collect brain waves for using it as part of the machine learning process, and basically many students willingly contributed with donating their brainwaves. And in terms of motivation, what is the motivation to implement this project and this system, right? So of course applications are plenty. We can use it for, we can see it being helpful and useful for impaired patients, either visually or even who eventually might have quadriplegia, and also it could also be used for in terms of cyberspace exploration, and even a critical mission, right? So of course there are many people that eventually cannot see, and eventually having a personal assistant as a humanoid robot that could help them would be a great aid, right? And of course it could even advance in terms of if you use it, a humanoid robot, not only in terms of, okay, I give a voice command and the robot goes and brings me something, but instead of it we can visualize using a humanoid robot in terms of, let's say, using it as an extension of your body, such as an avatar, right? So, of course, quadriplegia is, let's say, so far in medicine, is an irreversible situation, and basically having such a system will be very helpful, right? Okay, so of course this same platform we are implementing can also be applied for cyberspace exploration, right? So basically someone that eventually cannot, let's say, someone who is blind, right, can let's say go and use the system to allow the person to interact and do online searching, right, and even use social media. And of course the other applications also for mission critic or homeland security. Okay, so let's talk a little bit about the challenges we faced implementing this system, right? So one of the challenges was basically the human subject, right? So the human subject procedures actually took us a whole lot of work, right? Took us lots of, I would say about 2 months for us to prepare everything, to fill up all the forms, do the training, watch all the videos, and then finally be able to answer all the questions for the human subject board, and then they finally approved the project to go ahead, and we could finally collect brain waves from the students, right? So yes, just as I mentioned, right? So it was quite time consuming, right? And we needed to solve this challenge. But of course, we after 2 months working with the human subject committee, we got it approved, right? So the other thing, another few details we notice is that with the brain-computer interface, the sensor is kind of very sensitive, and basically when someone, let's say, anyone who wanted to donate the brain waves, if the person has long hair, we notice that normally the signal was not that strong, right? And on the other hand, whoever was donating the brainwave, either if the person has a shorter hair, it would help, and the brain sensors would basically collect the brainwaves, the neural signals in a stronger way, right? Okay, the other thing also that was a little bit challenging was because we want to integrate it and run the whole system on the cloud, and of course work with the robot at the same time, right? And the person who is thinking while the person is thinking, and we decided to choose Spark, right? So Spark as the platform for big data streaming, and basically we used it, but to mention what was that consumed us a lot of time was the MapR, right? So the MapR basically took us, I would say, a lot of work, but in the end, of course, we managed to do all the settings. Okay, in terms of system hardware architecture, right? So that's what we are using, right? We have the Now robot, as you can see, the HTC Vive for immersive virtual reality, also the Capital Glove for haptics, and of course the brain-computer interface, and besides we also use more like system, not much as hardware, the Storm, right? Well, initially we proposed the Storm, and at some point we switched from Storm to Apache, and for server we use the cloud on the server as the VPS, the virtual private server. And we compared all different sorts of options for cloud computing, right? So we compared AWS, Azure from Microsoft, and also Google, right? And then in the end, we decided to use VPS.net, right? So although the VPS.net has, let's say, not so easy to use platform, right? Not as easy as the AWS from Amazon or Azure or Google Cloud. But price-wise, VPS has a very competitive price, right? So this was one of the reasons we decided to go with the VPS.net. We also considered DigitalOcean, right? And one thing interesting about VPS.net is that they provide 24/7 technical support. So if something is not going the way you expect, you can contact them over online chat support, and they give you some feedback, right? Okay, so in terms of big data, of course, as part of the brain neuron signals, the amount of data is quite large. And what we did was we compared all different options for data analytics and data streaming. And in the end, we, after comparing all the possible options, initially we considered Storm, but then we moved it to Spark after last year, in the second semester, they announced that Spark now started also to have real-time features, right? So you can reach like a real-time streaming, which of course make it become more like let's say extremely low latency, right? And of course, other reason also to go with Spark is the fact that Spark has a huge job market, right? Which absolutely is more interesting, right? To make the project more attractive, and also to boost the students' chance to land in a good job after joining and participating in the project, right? Okay, so here we also see how the different data flow integrates, right? So we have the body motion sensors, we also have the Capital Glove and the HTC Vive. And then, of course, we could use the voice control, right, to the Now robot, but we decided that more interesting would be that we use the brain-computer interface, right? So which eventually, let's say if the person lost the ability to speak, right, and still want to have an avatar system, right, that would be the way to go, right? We save a number of, let's say, specific action or a specific thought to perform an action or a task in the database, and then after recording a certain number of sample for the data we are going to analyze, we run the machine learning, right? And then next step is we connect the data, right, with the either Storm or Spark, right, and we stream it to the Now robot who actually performed the action, right? Okay, so in terms of data integration, right, to make it smooth to, let's say, make the data analytics and all the other steps, we used the Panda, right, which Panda is a open source library and API to import numerical data, more like Excel sheet format. Then we go and we use Arrow to import from Panda and transfer it to TensorFlow, right? And then we go and we use Spark, right, just as a faster way to stream the data to the Now robot, right? So all these steps, right, are done, and although the Spark has its own machine learning library, we decided to use TensorFlow because TensorFlow has several advantages, and also is currently is the most popular machine learning and artificial intelligence library, open source library, which of course speed up the process, right? So when you implement and when you use tools, ideally you should, and that's one thing that we discussed with the team. We opt to use open source tools that are multi-platform, but also that has a high usage in the community, right? So which also help because if you need some to share something or to find material, you have more material. Okay, so here we have the overall view of the connectivity sequence, right? How the whole idea is implemented, right? So let's say the user, first we record a number of repeating thoughts with different, let's say, volunteers, and then we record it on the database. After that we are able to run several training sessions with the data, and after the model is trained, right, then we go and we use in real time, right, with some volunteer, right? So basically the person goes and thought, right, request a prediction, and it sends to BCI Hub, right, which is the system we were working and implemented. Then we also use the Flask web app, right, so to help to interface and send and receive the data. When this information goes to the cloud, it will end up in the machine learning model, which has been already trained, right? So as you can see, we have here we use the Spark data frame, right? And of course, based on what the machine learning from TensorFlow decided, then we have the result, right? So the result is nothing more than, okay, your brainwave signals got into our machine learning model, and based on the signal, the pattern, the design pattern of this signal match that example. For example, you want to raise your arm, or eventually you want to drink a coffee, right? And then what happened? The robot goes, as you can see, receive the information, right, and perform the action, right? Okay, so here we have the different parts and blocks that we coded to allow to integrate basically the action that the robot goes and perform, right? So as you can see, you have all the different actions, and for each one of the actions we need to have a specific data set, right? Or even if you want a database for that specific action, right? So and then of course according to what the person thought, will match the pattern of the brain waves, and the robot will perform that specific action, right? Okay, so of course, to get that accomplished, right, so we need to have a little bit of machine learning, right? And there are plenty of different models for pattern recognition and machine learning. The one we used was neural network, right? And the neural network basically is able to import the data, right? It's part of the coding. We import the data after we define and send the data through the pipeline, right? The machine learning classifier Go has a number of sample of the information, and once the model is trained, right, we are able to collect real-time data, and that data is automatically, let's say, matching what we have already defined in the database learning process. All right. Okay. So at the moment we have like 140 samples for specific actions, and also we have 105 samples for just thinking about an action, right? So and all that, of course, is accomplished through the brain-computer interface, right? So the concept of the brain-computer interface is to consider all the electrical signal that the brain neurons will fire whenever the person is thinking or doing certain action, right? Or even just thinking about something. One fact is that the first initial brain-computer interface was actually invasive, right? So, which of course is not so much, let's say, a kind of a thing that you would find much volunteers, right? Usually would be willing to test the initial brain-computer interface only eventually person who really want to have a little bit more capability, right? Normally patients with impaired condition like quadriplegia that would be either for the wish and the hope to start having mobility, or for the love of science to agree to volunteer, right? But hey, here's the good news. Now the BCI, brain-computer interface, is non-invasive, right? So which is of course fantastic, right? So there are different methods, right, and devices for brain-computer interface, and the one we are using is the OpenBCI, which is actually an EEG, right, that reads all the brain neuron signals, right? So basically, all these electrical signals, right, they fired, right, through the neurons whenever a specific thought or a specific action happens, right? The OpenBCI itself, right, so is a development kit that comes with different sensors and also Bluetooth connection, and it allows us to integrate it with a laptop or desktop, right? Put the cap on the head of the volunteer, right, and make the data transmission, right, using Bluetooth. Basically, what the user is thinking, that neuron signal is recorded by the sensors and send it wirelessly through the Bluetooth to the computer, right? So, and then in our system, the computer, we have the program that receives all the let's say amount of minutes we are reading a specific action, and then we load it on the cloud, right? Okay, so additionally, of course, the EEG has different sensors, right? For each type of a brain wave will be a more appropriate sensor, right? But basically, we use it mostly 8 sensors or 8 channels to allow us to record the data we wanted related to the thought or the action the person was intending to perform, and the robot actually goes and actually do what the person is supposed to be doing or supposed to be thinking. All right. So of course the brain has different areas which are more closely related to specific, let's say, tasks or thoughts, right? Basically the BCI, brain-computer interface, will take all that in consideration, right? And that's why and how we also are able to basically match some patterns according to the thought, right? Okay, so we of course we have, let's say, a set of data for the channels from the BCI, right? And we are using basically the NumPy as part of the package for the data treatment, right, or processing. We also use the OpenBCI Cython port, which is the communication port for the system, right? And then according to the channel, right, what the person is thinking is more active, we will go and we'll basically select, right, for each channel what is the brain or the neurons that are more activated, and we record it, right? So we add to the data set as a matrix, and at the end of a certain time frame we have a number of recorded information, right? So all this of course is important. So once we got the data, right, so next step is that we'll go and we load it to the cloud, right? We make the normalization of the data, and then of course after that the TensorFlow will go and match the pattern, right? So here we can see for specific actions, right? So how depending on the action, a specific channel will be more active, right? So as we mentioned, that different parts of the brain has more kind of a specific function, right? And therefore, according to the action or the thought, a specific area of the brain will be more active, and other parts or other sensors through all the cap, as you can see we have here a number of channels, right, will be more or less active, all right? Okay, so here we have some examples of the EEG signal, right? And as you can see, again, because we have several sensors, right, so we have lots of different signals for each one of the sensors, right? And despite that, what happened is after we run it on the TensorFlow with the neural networks, the TensorFlow is capable and able to fit what would be the highest probability of that brain signal that was just generated by the volunteer is actually a specific action that has been recorded and classified before, right? So again, we can see another example, right? Let's say if the person is reading, we will have a specific, let's say, brain signal, right? Which eventually will be different than if the person is thinking about kicking some ball, right? Or play volleyball or basketball, right? So according to the thought and according to the action, we have identified that the brain wave, the signals will be specific, right, and slightly different, right? And this information is enough for the neural network model be able to classify to match the pattern and basically define that, oh, this signal that we just received is related to, for example, the person is thinking about ice cream, right, and so on. But okay, so let's have a look in this short video, right, with an example, with a demo that we as a team have demonstrated the system working. Just a second.
All of this data has been collected in a controlled environment. So we are going to see how accurate of results we can get today. Here for you. On the left-hand side of the screen is the software that actually comes with the headset. And so I'm going to start connecting to the headset now. On the top right-hand corner, I'm showing what's going on inside of our server. And bottom right is the OpenBCI hub. So if I start the data stream, you can begin to see the brainwaves that are being picked up by from Sugo. We're going to just do a few adjustments until all of the sensors are picking up data. On this bottom right-hand side of their GUI is how we stream the data from the headset to our software. So without the software running, we cannot actually collect any data. Alright, it looks like we have everything hooked up. So it takes a couple of minutes, just a couple of seconds for someone's brainwaves to get down to sort of a normal level. We're getting to there now. We're going to start off by trying a couple of actions because those are a bit easier to predict. So first, Susan, I want you to go ahead and clench your jaw and begin. And you can stop. You can see the server is starting to move. Sure. And sure enough, we get our correct prediction. Jaw is the easiest to see because it has the highest electrical output from muscle input, from muscles in the head. So now we're going to try raising the left arm. So ready, begin. And you can lower your arm. Left hand. So you can see it came up with a couple of different outputs in our server. This is taken frame by frame. It's kind of like a video. And so this is sort of how it broke it down. So sometimes it can be wrong, but have detected partial correctness. So we can do another left hand and see if it gets it correct again. So raise your left hand again. Ready? Begin. And you can lower your arm. Excellent. Left hand. All right, now we'll try none. None is frequently difficult to get accurate and under high stress environments. So we will see if how calm Susan is at the moment.
Do you think you're stressed right now?
All right, ready, Susan? And I will begin recording now. You can start thinking again. So Susan was stressed out. So we got a jaw output. Now I'm going to switch over to the thoughts model. And of course this one is a bit trickier. And it frequently can't tell the difference between left and right. So we'll see what it comes up with in this setting currently. So start by thinking about raising your right hand. Ready? Begin. Right. Yes. So we got it.
All right. So as you could see, right, the system is able to, according to what is the thinking and the pattern of the brain waves, right, identify what would be the action the person is thinking about, and then the robot as an avatar, as basically an avatar, goes and perform the action, right? Okay, so in conclusion, right, what we have observed, right, through the work implementation is that, of course, this is a growing field of interest. Is a new topic, right? Applications are plenty, and of course, we have used cloud computing, right? Because it is a very flexible tool, right? And main contributions is the fact that we have investigated and we have proposed a platform for avatars, right? Okay, so, and of course, as you probably initially already mentioned, right? So this is an ongoing project, right? And of course, we have the contribution from many of the students who really enjoyed working and giving their contribution for the project, right? So of course, we acknowledge, right? And we thank each and every one of them, all right? Okay, so in case if you have any question, right? I will be here to answer, right? So I'll be more than happy to hear if you have any questions or any comments, right? And of course, I hope you have enjoyed the presentation, all right? So stay awesome, as always, and be nice to each other.